What's up everyone? Welcome to my channel. This video is about caster angles. In this video, you will learn what is caster, how caster affects the camber and handling characteristics of vehicle, what is mechanical trail. So without spending much time, let's start now. The caster angle is the slope of imaginary line that intersect the upper and lower steering pivot points when viewed from the side. These points could be the upper and lower ball joints for double wishbone geometry or the lower ball joint and the strut for the MacPherson geometry. So here you can see, this is the front wheel, the blue line is the vertical line passing from center, this is the upper ball joint and the lower ball joint of knuckle or upright. The axis passing from the upper and lower ball joint is called the steering axis or the kingpin axis. Currently you can see the red steering axis is parallel to the blue vertical line. This is called the zero caster. Now if we tilt the ball joint in the anti-clockwise direction, then the steering axis will be inclined towards the rear of car. This is called the positive caster. And if we tilt the ball joint in the clockwise direction, then the steering axis will be inclined towards the front of car and this is called the negative caster. Same is the case for MacPherson geometry. When the steering axis tilts towards the rear of car, it is called the positive caster, and if it is tilted towards the front of the car, it is called the negative caster. Now let's see how caster affects the camber and handling characteristics of vehicle. Caster angle affects the camber of wheel during steering. If the car is set up with the positive caster, the outside wheel will gain the negative camber while cornering and the inside wheel will gain the positive camber, effectively leaning the car into a turn, delivering the maximum contact path to the ground. Here you can see the tire is having a positive caster and as it turns, it provides the camber in tire. If this is the outer tire, then it will lead to negative camber, and if it is an inside tire, it will lead to positive camber. So changing the camber and leaning while turning can help in gaining better traction. Negative caster in this case creates an unstable effect and generally not preferred. Positive caster increases the steering effort, but this can be solved by using the power steering. Another important advantage of having a positive caster is that it provides the self-centering behavior of steering wheel. This happens because of mechanical trail. Mechanical trail, also called the caster trail, is the distance between the steering axis and the center vertical line of tire at contact patch. So, the distance between the blue line and the red steering axis at contact patch is called the mechanical trail. If we see the tire in top view and observe the contact patch, you will see the blue dot is for the center line and the red dot is for the steering axis. The distance between these two dots is called the mechanical trail. Now when we steer the tire, it will create a lateral force in this direction, and due to mechanical trail, the torque will be produced about the red dot. This will make the tire straight again on leaving the steering wheel. So due to mechanical trail, we get the torque per self-centering of steering wheel, and this torque is called self-aligning torque. So this is all about caster angle and mechanical trail. This much for this video. Thanks for watching. If you find the video useful, do like it, share it. Also subscribe to my channel, hit the bell icon to get the latest updates. If you want to check my blogs on vehicle dynamics, automobiles and software, you can check on my website. The link is in the description box. Till then, keep learning, keep exploring.